What are 35 HVAC secrets that can save you thousands over the life of your system without overlapping a single thing you've heard before? 28 years working out of a service van across Ohio, Pennsylvania, and now Texas, and I've got a fresh list. Every item below is something most homeowners don't know and most contractors won't volunteer. The premise is simple. Your HVAC system is mostly information theater. The contractor knows things you don't, prices the gap accordingly, and most of the gap closes the moment you know which questions to ask. None of what I'm about to walk through requires a trade license. Most of it requires a $30 multimeter, a phone camera, and the willingness to ask a contractor to put something in writing. Stick around to the end, because Secret 35 is the single piece of equipment that turns a homeowner into someone who can verify 90% of contractor airflow claims with a $50 tool most techs don't even carry. Number 1. The metering device dictates the charging method. Inside your evaporator coil, there's either a thermal expansion valve, called a TXV, or a fixed orifice piston. The TXV automatically adjusts refrigerant flow as load changes. The piston doesn't, it flows a fixed amount. The charging procedure is different. A TXV system is charged to a target subcooling number, which measures liquid line temperature below saturation. A piston system is charged to a target superheat number, which measures suction line temperature above saturation. Mixing them up causes chronic mischarge symptoms. When your tech is on a service call, ask him which metering device your system has and which target he's charging to. If he can't tell you, he's guessing with gauges. Took me about 4 years as an apprentice to get this clear in my own head, and the boss who finally drilled it into me did it by handing me a wrong charged system and telling me to figure out why it kept icing over. Number 2. The TXV sensing bulb has to be mounted right or the whole valve lies. The sensing bulb is a small metal cylinder clamped to the suction line that tells the TXV how much refrigerant to feed. If the installer clamps it onto a bare copper line without insulating over the top, ambient air temperature corrupts the reading and the valve overfeeds or underfeeds in cycles. Proper install means full insulation wrap with the bulb on the top of a horizontal suction line. Half the systems I've checked over the years had the bulb mounted at 4 o'clock or 6 o'clock instead of 12, which throws the calibration off by a few degrees of superheat. Easy thing to inspect with the cabinet panel off. Number 3. The square feet per ton sizing rule of thumb is wrong for modern homes. Contractors quote roughly 500 square feet per ton of cooling, which dates back to 1970s construction. A tightly built modern home with R49 attic insulation, low E windows, and decent air sealing often needs 700 to 900 square feet per ton. Oversized AC short cycles doesn't dehumidify and wears out the compressor faster. Demand a proper manual J-load calculation before any replacement, and walk away from any contractor who quotes you on square footage alone. Number 4. Return air ductwork is sized at 1 square inch per cubic feet per minute of system airflow. A 3-ton system moves roughly 1,200 cubic feet per minute, so the total return area should be at least 1,200 square inches. That's a return grill about the size of a typical doormat, or 2 smaller returns, adding up to the same total. Most older homes have 50 to 70% of the return area they actually need. The blower strains, static pressure climbs, and the indoor unit gets noisy. You can measure your return grill with a tape measure in 90 seconds. Number 5. The AC freeze misdiagnosis ladder. When your evaporator coil ices over, the cause is almost never low refrigerant first. The order of likelihood, from what I see on the routes I cover, runs about 70% dirty filter, 20% restricted airflow somewhere else like a kinked flex duct or a closed register, and 10% actual refrigerant issue. Contractors often skip the first 2 and go straight to refrigerant because refrigerant generates a bigger invoice. If your tech wants to add Freon without first verifying airflow at every register, that's the conversation to push back on. Number 6. Indoor air temperature stratification. The hot upstairs and cold downstairs problem is usually a duct balancing issue, not a missing zoning system. Most contractors sell $5,000 zoning to fix what $25 in trunk line dampers will fix. Inline manual dampers installed in the main supply trunks let you balance airflow between floors at the source instead of at each register. 20 minutes per damper to install if you can access the trunk in a basement or attic. The reason most homeowners haven't heard of this is contractors make zero margin on $25 parts. Number 7. Each MERV rating above 8 adds roughly 0.05 of an inch of water column to your system's static pressure. A typical residential system is designed for a total external static pressure of 0.5 inches of water column, about the pressure it takes to lift a sheet of paper into a fan. Install a MERV13 filter on a system already running near max static and you've pushed it into the red zone. Blower motor draws more amps, runs hotter, fails earlier. The filter aisle does not advertise this part. Number 8. A 4-inch deep media filter cabinet outperforms a 1-inch pleated filter at every MERV rating. The 4-inch cabinet has roughly 4 times the filter surface area, which means lower pressure drop at the same filtration level. A MERV16 in a 4-inch cabinet actually pulls less static than a MERV11 in a 1-inch slot. Install runs $300 to $600 but pays back in blower life and filter changes once every 6 to 12 months instead of monthly. Number 9. If your outdoor unit has been through a flood, hurricane, or sustained heavy rain after the disconnect tripped, before you trust it again, measure resistance from each compressor terminal to chassis ground. Anything below 1 megum means the windings have moisture intrusion and the compressor is on a countdown to failure. A $20 multimeter does this test in 90 seconds. Most contractors after a flood event will pull the unit, declare it dead, and quote replacement. Sometimes they're right. Sometimes the Megum test would have told you it had 2 more good seasons in it. Number 10. Compressor compression ratio is the diagnostic most techs never run. Compression ratio is the high side pressure divided by the low side pressure. On a healthy R410A cooling system at design conditions, you should see roughly 2.5 to 3.5. If the ratio climbs above 4:1 with clean coils, proper airflow, and correct charge, internal compressor wear is the most likely cause. It's the earliest sign that a compressor is on borrowed time, usually 6 to 12 months before the unit dies. Most homeowners replace systems 3 to 5 seasons too late because nobody was watching the ratio. Number 11. When the thermostat goes dead and nothing happens at the air handler, listen at the unit. A faint hum from the low-voltage transformer means it's alive and the problem is upstream. Silence means the transformer is fried. $25 part, 5-minute swap. Most service calls for dead thermostats are this. Number 12. The spade connectors on your capacitor terminals corrode in humid climates, and the corrosion mimics capacitor failure. The capacitor reads fine on a microfarad meter, but the unit short cycles or won't start. Pull the spade connectors off, brush them clean with a small wire brush, apply a dab of dielectric grease, and reconnect. $4 tube of grease prevents 20 service calls. I missed this on my first year of capacitor diagnostics until an old-timer at the supply house counter laughed and showed me. Number 13. Once a year, with the disconnect pulled, open the outdoor disconnect box itself and check the fuse cartridges for green corrosion at the contact tabs. Tighten the lug screws on the line side and load side wires. Loose lugs heat up under load. That's how outdoor disconnect fires actually start. 2-minute inspection that nobody schedules, and that's quietly burned down more units than any single failure mode I can name. Number 14. ECM blower motors and PSC blower motors fail differently and diagnose differently. PSC motors, the older single-speed type, fail with bad bearings or a bad run capacitor and you'll hear it coming. ECM motors, the electronically commutated type used on newer systems, fail at the integrated motor module, which is a control board built into the motor housing. ECM failures throw fault codes through the thermostat. Before you let a contractor replace the whole ECM motor at $800 to $1,200, ask if the module alone can be swapped for under $300. On most Carrier, Trane, and Lennox systems, it can. Number 15. Bypass damper zoning systems cause more problems than they solve. The bypass damper, which dumps unused supply air back into the return when zones close, raises static pressure, drops latent heat removal, and short cycles the compressor. I used to recommend bypass zoning on most retrofit jobs about 15 years ago, until I started seeing the failure pattern on systems I'd installed 3 to 4 years earlier. Now I tell homeowners with comfort imbalance problems to fix the ducts first and only consider real VAV zoning with no bypass as a last resort. If a contractor quotes you bypass damper zoning, ask him about the static pressure implications and watch how he answers. Number 16. The 24-volt control test diagnoses most thermostat issues in 5 minutes with a $15 multimeter. Set the meter to AC voltage. Touch the leads to the R and C terminals at the thermostat. You should read 24 volts. Then call for heat at the stat and touch R to W. Should still read 24 volts. Call for cool, touch R to Y. Same. Fan, R to G. Same. If any of those reads 0, you've located the broken control circuit before paying a tech to find it. Number 17. The reversing valve on a heat pump can wear out part way, where it shifts but doesn't fully seat. Symptom is reduced capacity in either heating or cooling mode, but not both. The diagnostic is a temperature split test in both modes. Cooling mode should show about a 16 to 22 degree drop across the indoor coil. Heating mode should show about a 20 to 30 degree rise. If one is off and the other is normal, the reversing valve is your suspect. If you're getting value out of this, hit subscribe. We've got more of these coming. Back to it. Number 18. Heat pump defrost cycles are usually set on a timed default of 30 minutes regardless of weather. Better boards offer demand defrost, which only initiates when the outdoor coil actually frosts up. Switching from time to demand defrost, where the board allows, saves about 5 to 10% on shoulder season heating bills. Look at your control board for a jumper labeled defrost interval or demand. 2-second adjustment, lifetime savings. Number 19. Suction line ice on a heat pump in winter is not a refrigerant problem. It's a defrost cycle problem. The defrost board is either failing to initiate the cycle on time or the defrost thermostat sensor has lost contact with the coil. Don't let a contractor sell you a recharge for a control board issue. The recharge will mask the symptom for one cycle, then come right back. Number 20. As of 2025, new HVAC equipment ships with R454B refrigerant, mildly flammable and classified A2L, R410. A systems cannot be retrofitted to R454B. The refrigerants are incompatible at the equipment level. Contractors quoting you a retrofit on an R410A system are either misinformed or running a scam. A switch from R410A to R454B requires a complete equipment replacement, indoor coil, outdoor unit, and line set service. Number 21. If you still have an R22 system, the math on repair versus replace has shifted hard. R22 was phased out under the Clean Air Act and current pricing runs about $150 a pound, sometimes higher. A typical 3-ton recharge needs 6 to 8 pounds, plus labor, plus a leak repair. One service call easily hits $1,500. 2 more in the same year, and you've spent the down payment on a new system. At that pricing, end-of-season replacement during October through February in southern climates almost always wins. Number 22. When a contractor replaces your outdoor unit and reuses the existing copper line set, code and manufacturer warranty require a documented line set flush and pressure test. Most installers skip the flush, use a quick nitrogen sweep instead, and never document the pressure test. On R454B installs, missing either step voids the manufacturer warranty. Ask for both procedures in writing on the install paperwork before final payment. Number 23. Most smart thermostats from Ecobee Nest and Honeywell have a hidden dehumidify mode that overcools by 1 to 2 degrees Fahrenheit when indoor humidity rises above your set point. Most installers leave it disabled because they don't know it's there. Enable it through the installer menu, and your humid summer days get significantly more comfortable for 0 extra equipment cost. Number 24. The fan-only delay setting on a smart thermostat keeps the blower running after the compressor shuts down to recover cooling left in the cold coil. Default is usually 0 seconds. Set it to 60 to 90 seconds and you capture 5 to 8% more cooling per cycle, free. Look for the setting under Installer or Advanced Menu Options. Number 25. If your thermostat doesn't have a C-wire and you want a smart thermostat, a $20 C-wire adapter from Venstar or Honeywell works perfectly fine. Contractors regularly quote $200 to $400 to physically run a new C-wire from the air handler to the thermostat. The adapter solves the problem in 15 minutes with no wall fishing. Number 26. In Texas, Florida, Arizona, and most southern climates, the math on a 95% AFUE high-efficiency furnace versus an 80% AFUE standard furnace rarely pays back. Heating runtime in those climates is short enough that the gas savings don't recover the $1,500 to $2,500 install premium within the equipment's life. In Pennsylvania or Ohio, the math goes the other way and 95% is the right call. Ask for the payback calculation in writing and check the assumed annual heating hours. Number 27. Most mini-split indoor heads have a hidden hard reset sequence. On a Mitsubishi or Daikin, it's usually holding the reset pinhole or pressing a button sequence on the remote. Resolves about half the software glitches that contractors charge a $150 diagnostic to clear. Look up your specific model and write the sequence on a sticky note inside the head cabinet. Number 28. If your indoor air handler has a condensate pump separate from the gravity drain, test the pump annually by pouring a quart of water into the pump reservoir. The pump should activate within seconds and clear the reservoir. Pump failure causes the same sealing damage as a clogged drain, and the float switch on a pump is independent of any drain pan float switch you may have tested separately. Number 29. When you clean a blower wheel, the wheel needs to stay balanced. Dirt accumulation often happens unevenly, and aggressive cleaning can throw the balance off if you remove deposits from one blade more than another. Quiet running blower? Leave it alone or clean lightly. Loud or vibrating after cleaning? The wheel needs to be rebalanced or replaced. Some old-timers in the trade tell apprentices to never deep clean a wheel that's running quiet, and it took me a long time to understand why. Number 30. Horizontal air handlers, the kind that lie on their side in attics, need the drain pan checked for slope. Code requires the pan to drain toward the outlet. Settled framing or a unit installed slightly off level lets water pool at the wrong end of the pan, which rots the metal and eventually drips through the ceiling below. 20-second check with a torpedo level. If the pan tilts away from the drain, shim the unit. Number 31. The compressor's running amp draw should be roughly half its locked rotor amp value, which is printed on the data plate. If running amps creep above 2/3 of locked rotor amps under normal load, you're watching a compressor lose internal efficiency. Trend it year over year with a clamp meter and you'll catch failures roughly 6 months early. Number 32. A residential blower door test run by a certified energy auditor costs $200 to $300 and tells you the exact air infiltration rate of your house, measured in air changes per hour. That number is more useful for diagnosing comfort and efficiency problems than any HVAC service call you'll ever pay for. A typical 1980s house leaks at 6 to 10 air changes per hour. A tight modern home runs 2 to 4. Knowing your number tells you whether to spend money on equipment upgrades or on envelope sealing first. Number 33. The day a contractor finishes installing new equipment, walk outside with a phone and photograph the data plate on the new condenser. Get the model number, serial number, refrigerant type, charge weight, and SEER rating in the photo. Some contractors, not many but enough to matter, will install a different SEER tier than what's on the contract and leave the old data sticker, betting you'll never check. The photo protects you on warranty claims and on resale disclosures. Number 34. Every matched HVAC install should come with an AHRI certificate, the Certificate of Product Performance issued by the Air Conditioning, Heating, and Refrigeration Institute. The certificate proves your indoor coil, outdoor unit, and metering device are tested as a matched system at the rated efficiency. Without that certificate, your manufacturer warranty terms default to mismatched system rules, which usually cuts coverage in half. You can verify any matched system free at ahridirectory.org by entering the model numbers. The contractor never tells you this exists because mismatched installs are common and the certificate paperwork is annoying. Quick stop before the climax. Knowing 34 things doesn't mean you skip every contractor. Anything involving refrigerant requires EPA 608 certification under federal law. Anything involving the gas valve, the burners, or the heat exchanger requires a licensed pro with proper combustion analyzer testing. Sealed system internal repairs require shop equipment most homeowners shouldn't own. The point of this video is to make you the kind of customer the contractor respects, the one who asks for the AHRI certificate, the static pressure reading, and the line set flush in writing. That customer pays less and gets better service. And number 35, the $50 tool that turns you into someone who can verify 90% of HVAC airflow claims. A handheld digital manometer, a small electronic gauge that measures static pressure in inches of water column. Brands like Fieldpiece, Testo, or even cheaper Amazon units run $40 to $80. With 2 small probe ports drilled in your supply plenum and return plenum, accessible with a $5 set of test ports, you can measure your system's total external static pressure in about 30 seconds. Manufacturer max on most residential equipment is 0.5 inches of water column, about the pressure it takes to lift a sheet of paper into a fan. If your system reads above 0.7, you have an airflow problem somewhere. Filter, duct, coil, return area. Take your pick. Above 0.9, you're killing the blower motor and shortening the compressor life. Think about that. A $50 tool, $5 test ports, 30-second measurement. After that, every time a contractor tells you your airflow is fine, you can ask him to show his readings. If his number doesn't match yours within a few hundredths, one of you is wrong, and now it's a conversation, not a sales pitch. Most homeowners go a lifetime without measuring static pressure. The ones who do find out their system has been screaming at them for years, and the techs never bothered to listen. 35 secrets, none of which are theoretical. Pick 3. Run them this weekend. Read the data plate. Test the 24-volt control circuit. Photograph your equipment before the next contractor leaves. The system you already own has more life in it than anyone selling you a replacement wants to admit. And once you've got a manometer in the drawer, the entire HVAC industry starts treating you differently. They can feel it in the first 10 minutes of the call.